Now this is a pension planning example, and this has a unique feature. We'll come to that in just a second. The problem here is that we want to allocate some amount of money and buy these three different bonds: bond 1, bond 2, bond 3. So each of these three bonds have different costs and different revenues coming in future years. Okay? So now we have to allocate a certain amount of money. How much we have to decide, and how much of that money should go into each of these three different bonds. That's also a decision that we have to make. So there are three decision variables. One is how much money we need to allocate, and how much of that money should go into these three different bonds. Now the interesting thing here is the objective for us is to meet the pension obligations, okay, at the same time minimize the amount of money that we have to allocate at the beginning. So in this example, one of the decision variables itself is the objective function. Okay, that's the interesting aspect of this problem. So let's go to the Excel file, okay, and here let's look at the input data. Okay, so here these are the inputs. Okay, you have to be very careful here. The first column is cost, that is cash going out. Okay, and the rest of them are cash coming in. Okay, so you have to keep that in mind. So this is the interest rate, and here we have to figure out how many dollars we'll have to spend in each of these and how much money should be allocated. So that is also a decision variable, and this is objective to minimize as well. Okay. Now the constraints are that we meet the pension obligation. So these are the pension obligations. These are given. So that's input. Okay, so let's give some names here. Okay. Define. Bond investments. Okay. Now amount available is how much money we have allocated, and then some of which will be used for buying bonds. So these are the number of bonds that we will be buying times those. So that will be the amount we have to shell out for buying bonds, and this is the total money allocated. So the difference is available for payout for the first year. Now for amount available for the second year onwards, okay, we have to take a look at how much cash will be available and add the revenue coming from bonds. So let's add one more row here. Cash in bank. Okay. So that would be the amount available minus amount required. Okay. So that would be the cash that would be left over. So here our cash available will be, you take cash in bank, then you multiply by 1 plus the interest rate. Okay, so now let's give a name to this. So cash available would be, or amount available will be, first let's look at how much the cash will be worth now. which is leftover cash times 1 plus interest rate plus bond revenue. Bond revenue will be some product of how many bonds we have bought with the bond payoff. So cash after interest and then the bond revenue. Okay, copy that. Okay, and we have to copy this as well. And all of that amount available should be greater than or equal to the amount required. So let's give a name here and name here as well. And now let's run solver. Our objective is money allocated, which should be minimized, and we need to know how many bonds we have to buy and how much money to allocate. So B16 is both objective function to minimize and a changing cell. The constraint that we need is amount available should be greater than or equal to amount required. Non-negative, simplex LP, you solve, and you have the answer. So this is, let's reduce the, maybe we need to increase the column width, and we have the answer. Now we can run a solver table with the interest rate being different. So you can go to run solver table and one-way table, interest rate going from 2%, so that will be 0.02. Okay, remember you need to type this in as decimal values, 0.06. Okay, increasing at the rate of 0.4%, so that will be 0.004. And as output, we want how many bonds we are going to purchase and how much money we need to allocate. And these are, you have to increase the decimal places to see actually